Hello and welcome to Module 6, Lesson 4, the fourth and final lesson in this module. And in this module lesson, we're going to look at limiting reagents, excess reagents, and percent yields. So limiting reagent or reactant, I'm going to switch between the two, it's the same thing. Limiting reagent is the reagent that is completely used up and determines the amount of product that can be made. Therefore, the excess reagent is the thing that you have remaining. So it's kind of like a recipe. If I have 6 slices of bread, if I have 10 slices of cheese and 2 slices of meat, let's say turkey. And to make a sandwich, the recipe calls for 2 pieces of bread. We really like cheese, 3 slices of cheese, and 2 slices of turkey. Well, how many sandwiches can I make if this is what I have? I can make 1 sandwich. Why? Well, I am limited by the amount of turkey I have. Therefore, the turkey would be the limiting reactant. In excess would be the bread and cheese. Now we could make grilled cheese, but we're not making sandwiches here. We're just looking at this. So that's the idea of what we're looking at. And we have to do, of course, stoichiometry calculations to determine that. So limiting reactant problems are simply 2 stoichiometry problems in one. Change each reactant into moles or grams of the same product. That's the important part. We have to do it to the same product. We have to compare apples and apples, not apples and oranges. The reactant that produces the least amount of product is the limiting reagent. I don't know how to highlight on this, but I'm just going to say this part right here. The reactant that produces the least amount of product is the limiting reagent. And that, in theory, is how much you should make. Okay, so let's do some problems. So it says when sulfur reacts with chlorine gas, sulfur pentachloride is formed, and it specifies that sulfur is S8. Okay, so we'll start with our balanced equation, S8 plus chlorine gas reacts to produce sulfur pentachloride. We're going to balance it, 8, and it's going to be 20 moles of chlorine. So if 15.07 grams of sulfur and 100.7 grams of chlorine react, how much product can be formed? So in this case, we're going to do our 2 stoichiometry problems from the reactants that were given, grams of sulfur and 100.7 grams of chlorine. And we're going to go to the product. In this case, there's only 1 product, so we don't have to figure out which one we're going to. So we're going to take grams of our sulfur and grams of chlorine and do 2 separate stoichiometry problems to determine the grams of the sulfur pentachloride. 1 mole of S8 is 256.8 grams. And then we're going to go from moles of sulfur to moles of sulfur pentachloride. And then from moles of sulfur pentachloride to grams of sulfur pentachloride. Okay, so based on our balanced equation, 1 mole of sulfur is equal to 8 moles of sulfur pentachloride. 1 mole of sulfur pentachloride is 209.35 grams. The other one, 1 mole of chlorine gas, 35.45 times 2, which is 70.9 grams. And then we're going to go from moles of chlorine to moles of SCl5. And so that's still going to be 8 there, and it's going to be 20 on the bottom. Now, when you're doing a limiting reagent problem, the last 2 steps in each of your separate stoichiometry problems should be the same if you're going to grams, because you're going to the same product. So the top answer gives me, I do that math, 98.28 grams of SCl5. The bottom answer gives me 118 0.9 grams of FCl5. So let's think about this. Which one is the limiting reagent? The limiting reagent is the one that produces the least amount of product, okay? 98.28 is your least amount of product. That means that S8 is your limiting reagent. What would be the excess reagent? That would be chlorine. Oh, no, that's not what I wanted to write. I wanted to write excess reagent. How much will actually be made? The 98.28 grams of SCl5 should actually be made, okay? This is what we should actually make, okay? And then how much of the excess reactant remains after the reaction is completed? There are a few different avenues to take in order to answer this question, but the way I like to do it is I like to take the number that you should make and work backwards to determine, well, how much of the excess do I need to make that? So let me clear this. So you should pause to get that if you need. I'm going to clear this, and we're going to start with our 98.28 grams of SCl5. This is what we call our theoretical yield. So you take your theoretical yield, so that is what you should in theory make based on your calculation. And based off my calculations, I'm going to make 98.28 grams. So we're going to start with our theoretical yield, and we're going to work backwards to the excess reagent. (209.35 grams SCl5, 1 mole SCl5. So it's 8 moles SCl5 to 20 moles of chlorine, because that was our excess. And then we turn it into grams. What does this give me? This gives me 83.21 grams of chlorine. That is how much was used, okay? It takes 83.21 grams of chlorine to make our theoretical yield of 98.28 grams. Now, what do I just do? Well, I take how much I started with. I subtract the 83.21 grams, which is what I used, and I get 17.49 grams of chlorine, which is what remains. Okay, so if you start with your theoretical yield, work backwards to the excess reagent, that tells you how much of the excess reagent was used. Take the difference between what you started with and what you used, and that will give you what remains. Simple. Again, this is nothing new here. We're just doing more, okay? Not new, just more. Okay, and then the last page. So the theoretical yield, again, the amount of product based on your reactant values, what you should in theory make. The actual yield is the amount of product actually made. You either need to perform an experiment to determine the actual yield, or it needs to explicitly tell you. So percent yield, you just take the actual divided by the theoretical yield, multiplied by 100. So it says 0.5 gram of silver nitrate reacts with 30 grams of potassium chromate to yield 0.455 grams of silver chromate, and then potassium nitrate. What is the percent yield? Okay, first thing I need to do, you guessed it, balanced equation. Silver nitrate reacts with potassium chromate to yield silver chromate and potassium nitrate. Balance it, 2 there, 2 there. There you go. So we have 0.5 grams of silver nitrate, and we have 30.0 grams of potassium chromate. We have to turn these into a product. Which product do I turn them in? I have two. I have silver chromate or I have potassium nitrate. Well, I'm going to go to silver chromate because I know the actual yield. So I need to determine the theoretical yield for that compound. Okay. So 1 mole silver nitrate, that's going to be 169.88 grams. And then for every 2 moles silver nitrate, again, based on our balanced equation, you get 1 mole of silver chromate, and then 1 mole of silver chromate will give me 331.73 grams of silver chromate. That answer, 0.5 grams silver chromate. Okay, so that's one of my answers. And we do the same thing for the potassium chromate. It's going to be 194.19 for its molar mass. Then our mole ratio, 1 mole of potassium chromate for every 1 mole of silver chromate. And then again, our last steps are always the same. That gives me 51.2 grams of silver chromate. So it's quite clear which one is your limiting reagent. The silver nitrate is your limiting reagent because it produces the least amount of product. That makes this your theoretical yield. I have my theoretical yield. I have my actual yield. We can go ahead and calculate a percent yield. So actual divided by theoretical, multiplied by 100. If you follow sig figs, your answer is going to be 90%, which is a good yield, okay? So I made 90% of what I should have. In theory, I should have made half of a gram. In actuality, I made 0.455 grams, which is good. 90% is good. If you're doing anything in the lab and you get over 70%, you're doing good, okay? So please do keep that in mind. There is one thing, I guess you could ask yourself, can I get a percent yield over 100? And the answer is yes. But long story short, you made a mistake somewhere in your procedure. Okay, something went wrong and now you have more than you actually should. You didn't filter something right, you left something in, something's not dry. There are lots of different scenarios where you could actually have over 100%, but that comes from a human error. So that's it. Again, nothing really new here. We've got a new formula for percent yield, but we're doing the same stoichiometry problems, okay? Following along on your mole map. And again, these notes, this note's not very long. Now you have time to do the practice. It's all about practice, repetition. The more you do it, the better you get at it, the easier it's going to be for you. So of course, if you have any questions, please let me know. Ask them in the chat, ask them at the end of class. So that's it for this module. Yeah, see you later.